for anyone that wanted to rewatch this or who missed the class per se. So take a moment, read the do now, and then answer the questions. I'm going to ask you to pause me again if you want more time, but just for the video recording, I'm going to get going in a second, okay? So go ahead, read it, answer it in your notebook, or if you printed it up right in the paper. Okay, so Daniel and his cousin both collect stamps. Daniel has 56 stamps, and his cousin has 80 stamps. Both have recently joined different stamp collecting clubs. Daniel's club will send him 12 new stamps per month. His cousin's club will send his cousin 8 new stamps per month. How many months will it take for Daniel and his cousins to have the same number of stamps? Let's go to write down some information first. We have Daniel. He has 56 stamps. And he's going to get, well, what else do we know about Daniel? So someone would say, oh, he gets 12 per month, right? So he's going to add 12 new stamps per month. And his cousin, which we don't know his cousin's name, his cousin has 80 stamps to start with, right? And the cousin's going to get 8 new stamps per month. Okay, so let's go back to the question. How many months will it take for Daniel and his cousin to have the same number of stamps? Well, Daniel obviously has less. Will Daniel be able to catch up to his cousin? What do you think? Will Daniel be able to catch up with his cousin? And I would ask the student, and they would say, yeah, because Daniel's getting 12 more per month. His cousin's getting 8, so Daniel's getting 4 more than his cousin. So every month he'll get 4 more stamps closer to what it is. So I guess we could, what was anyone thinking? Anyone make a table to figure it out? And then people would say, yeah, we made a table. And I would push everyone to, anyone try to write an equation that might help us do this? And someone often raised their hands. And I said, okay, so what's the equation you wrote? And they would say, well, 56 plus 12x equals 80 plus 8x. And I would say, great. And I'd say, where did you come up with that? And then a student would say, well, Daniel had 56 and he's going to gain 12 per month. And that often has a variable. The months will change. And the cousin has 80 and it's going to get 8 per month. And we want to know when they'll have the same. And same often means equal. That would be great. And a table's just as great, but equations might get us there slightly quicker. So if you haven't, go ahead and write this equation down. Cool. And now we're going to solve it. So we'll take 8x away from both sides. There's many ways to do it. I always work with the variables first. Take a 56. And I would invite a student to come up and do this, but I'm here by myself. All right. So once I solve it, I find that it's going to take 6 months for them to have the same number of stamps. And I would ask any questions. And you would get that by making a table and adding, but that was one thing. Okay, and the last question, which they always like to ask, is how many stamps will that be? So after 6 months, how many stamps will they have that's the same? Well, we can do either person. That's a way to check. Let's take Daniel's cousin. He has 80, and he's going to get 8 per month for 6 months. So they're going to have 128 stamps after 6 months, and that's when they'll be caught up. And then after that, Daniel's going to take over from Okay, so that's the do now. We would be answering questions for homework, but you'd message me if you wanted to see the video for the homework. I'd post it as well. But for now, we're going to jump into our notes. So we're going to another section. We just finished with proportions, but we're going to go into, this is probably a very new topic for many of you. You probably haven't did this at all in 7th grade, even if you had a normal year. So this is 1.6. We're solving equations for a variable. And you're going to say, Mr. Moran, isn't that what we've always been doing, solving equations and variables? And I'm going to say yes, but different, okay? So let's talk about how it's going to be different. And I'm going to connect it to stuff you already know. So, circles. No, we're not doing circles. We're not. We're just thinking about circles to help us with our new idea. So, the figure shows a circle within a square. Find the circumference of the circle using the given formula. So the circumference is 2 times pi times r. And does anyone know what r stands for in this formula? I know you've used it maybe in 5th and 6th and 7th grade. You can just say it if you know it. Nice. Radius, yeah, totally, it's the radius. So the radius is only the halfway across. Do you know how halfway across through the center of the circle is? It's 4. Cool. So we can just use our formula and we get 8 pi inches squared. Cool. And your teachers hopefully talked about leaving in terms of pi. It's just easier. We do it a lot when we're older. Cool. All right, our second one is, what if we knew the circumference this time of a different circle? Could you find the length of the radius? And what would you do to find it, right? So, without students here, it gets a little tricky, but I would ask you to turn to your partner and see, could you figure out what the radius was if you only knew the circumference was 20 pi? Think about it, right? If we knew the radius, we could get the circumference. Could we go backwards if we knew the circumference to get the radius? So then, pause me now if you want to think more about it, or I'm going to jump in. Well, we know the circumference, so we could actually put it in our formula. Right? And then we just need to figure out, hey, what number would work for r? And someone might say 10. And I would say, yeah, totally 10 inches. That works, right? And I'll show you this later, but we can actually solve it if we wanted to. So cool. So yeah, we can get 10. All right. So, is there a way to rewrite the problem, change the formula? So instead of finding the circumference over here, you put r in, you get the circumference. If you put the circumference in, you get the radius. So is there a way, if the radius is unknown, we want to find the radius, how would we get it? And so you talk to your neighbor and you turn and talk and be like, oh God, well just think about it. We had 20 pi equals 2 pi r. So, and our answer was 10, so how might we do it? Right? And, right, because this only gives us circumference. So, someone often says it's circumference divided by 2 pi. And I would say, yes, totally. We take our circumference and we divide it by 2 pi. And we get our radius every single time. Cool. And you're kind of there, you're kind of figuring out there is an algebraic way to turn this into that. Okay? And that's what we're going to get to. We're trying to figure out how to turn this into that. And that's what we mean today about solving an equation for a variable. Okay. You don't need to write this down, but if you have it printed out. Can we get someone to read it for us? Yes, I'll read it. A literal equation is an equation with two or more variables. To solve one of the variables, use your inverse operations. Great. Thank you so much for reading that. So, I'm never going to ask it, but we consider equations that have one or more variable, two or more variables, excuse me. We call them literal equations. I'm just going to call them equations. You can call them equations, but that's what mathematicians talk about. And what we're going to talk about is solving literal equations today. Okay, take a moment, write this down. Solve the equation. Boom. Sweet. All right, but we've been leaving something out up to this point because before we would just tell you to solve the equation. Sometimes we would, but we leave it out when there's only one variable. We don't have to say this next part. But what are we really solving this equation for? Well, we're actually solving the equation for x. Okay, so this is a simple one. We've been doing it, at the beginning of the school year. So how do we solve this one? Well, we take away 4 from both sides. Sweet. And then what would you do to both sides? You divide by 3, right? And then we get x equals 1. So there's what we do to get our answer. Sweet. But what if I replaced the 4 with a y? We're still, and this is our new idea, we're still going to have to solve the equation. Okay? And again, they left it out, but once we have two variables, we're going to say what we're going to do. We're going to solve this one for x again. Okay. Now, to solve this one for x, it's the same process as the one you just saw. So we have to get x by itself. So what do you think we do to both sides to get x by itself? Well, what do we do up here? We're going to do the same down here. We take away y from both sides. Sweet. Hopefully you said that. Y, take away y is gone. And now we're left with 3x on this side. And we talked a little bit about this. Can you take y away from 7 and get a different answer? No. So guess what? You just write it as y. You can't simplify it. Minus 7 minus y. Mr. Ryan, that's it? Yeah, that's it. You can't simplify it, so that's what you get. All right. Now, we have 3x equals 7 minus y. Now, what did we do here to get x by itself? Same right here. Bango, bingo, boom. Divide both sides by 3. 3 divided by 3 is 1. So we get x equals 7 minus y over 3. And, sorry you can't see that, we just solved it for x. That's it? Yeah, that's it. Can't do anything more with it. We just solved this for x. What do you think? That's it. We have, yeah, that's all you can do. It's almost easier than solving regular equations. You'll see. Okay. But now you have to be very careful. Once you have more than one variable, the directions will tell you to maybe solve for the other variables. So instead of solving this for x, we can actually solve this for y. All right, so how are we going to get the y by itself? What can we do to both sides? Yep, you nailed it. Take away 3x from both sides. So we get y equals 7, take away 3x. That's it. We just solved it. I know. Simpler, right? No work. You just have to get the variable that you're solving for by itself. That's it. Boom. All right. Any questions so far? Good. Okay. You can always ask when you're back in class or you're there for a live class. All right. So we're going to do some more examples. There's a lot of different types of solving for variables once there's more than one. So I'm going to do one you know how to do, and then switch it up, okay? So for the next couple, we're always going to solve for z, okay? All right. So number one, 2z plus 5 equals 10. This only has one variable, so we know how to solve it. We would take away 5. Then to get z by itself, we divide by 2. And then you find that z equals 5 over 2. Sweet. All right, but we're going to mix it up a little bit. I'm going to change a bunch of stuff. Instead of the 2, I'm going to turn it to a k, so kz plus, not a 5, but we're going to call it 5x. And not a 10, we're going to call it 6y. Okay. But the process to solve for z is the same thing we just did. Okay. And because it can get confusing, I highly recommend you just darkening in the variable you're going to solve for. So go ahead and write this one down. And we're going to try to get z by itself. You ready? Okay. What's the first thing we did to get z by itself on the first one? Took away 5. Okay. What do you think we're going to do here? Yes. Take away 5x from both sides. Positive 5 minus 5 is gone. So now we have kz equals 6y minus 5x. Okay. And these are not like terms. Can't do anything with them. All right. Again, I recommend you highlighting the variable you're trying to get for, right? We have kz. We're trying to get z by itself. Up here, we divided both sides by 2. So guess what we're going to do down here to get the z by itself? We're going to divide both sides by k. Boom. Okay, so divide both sides by k. Anything divided by itself is 1, so that's great. And we find that z equals 6y minus 5x, all of it divided by k. There we go. Sweet. So look, it's all the same steps. Take away 5, take away 5x, divide by 2, divide by k. There we go. Okay. Let's see, is that the one I want to do? Yeah, sure. Okay. So, just to help you, because I know students get a little tricked up here, go ahead and write this one down. It's similar, but instead of multiplying z by k, we're going to divide it by k. All right. So, how are we going to get z by itself? Well, we're still going to take away 5x from both sides. Okay. Now, easy to forget, but how are we going to undo this divide by k? This one right here. How are we going to do this divide by k? Well, we're going to have to, how do you undo division? Totally. You have to undo it with multiplication. So, we write this guy down here. So, we'll multiply both sides by k. So, it cancels this out. And you have z equals 6y minus 5x times k. Cool, except I did something wrong. We have to multiply both sides by k. Look at the way I wrote this. Did I really multiply this entire side times k? Someone will say yeah. Actually, the answer is no, because right now it's only saying that I multiplied 5x by k. So what I have to do is put parentheses around my 6y minus 5x, because I want to multiply the entire side by k. Oop, hold on. I must not have it plugged in. No, I did. Guess I haven't touched the buttons in a while. All right. Long lesson, no doubt. One more type for you, and then we'll stop because we'll take another day on it. All right. So, write this one down. All right. This one is not a literal equation because you only have one type of variable, z. So, we have 4z plus 10 equals 2z plus 12. This is very much like the bags and coins problem. So, what's the first thing we want to do to solve this equation? Some of you might say take 10 away from both sides, and I would be fine with that. Okay, now what? Well, we have z on both sides, so I got to move it over to one of the other sides. Undo it from one side. And then our last step is divide both sides by 2. So we get that z equals 1. Okay, so that took us 1, 2, 3 steps. Okay, find the z is 1. All right, so to change this one up, though the process will be the same, I have 4z plus, instead of 10, I'm going to put a b. 2z will keep 2z, and the 12 will turn to c. Cool thing is, we can do all the exact same steps. All right, you ready? All right, the directions say to solve for z. It's really important that we see that z is on both sides of the equation. Okay. And we're lucky we can do the exact same process. You ready? What's the first thing we did to both sides up here? We took away 10. So we can do that here. We can take away b. b minus b is 0, so we get 4z equals 2z plus c, and we can't take c away from b. We can't simplify it, excuse me. So we're just going to write it as minus b. And that's okay. All right, what was the next thing we did in the equation before? Well, we got rid of the 2z, and we can do that exact same process here. Move the 2z over. So 4z take away 2z is 2z. This got canceled, and left with c minus b on this side. And then our last step here was just to divide both sides by 2. And we can do that method right here by dividing both sides by 2. 2, it undoes itself, so we're left with z equals c minus b over 2. I would take questions, but this is a recording. But you can see it's the same stuff, right? You've been doing it. We just don't have to do as much math. We just make sure we think about where z is, what we're trying to solve for. In this case, it was z. And we got what z equals. Sweet. So your classwork, which is right here, which is to finish for homework. Okay, so make sure you show your steps. And I have the answers to the first couple, but 14 through 18 and 20 through 26. Make sure you watch what it's asking you to solve for, okay? You might have had a couple minutes in class to get started so I can check in with you. But there you go, okay? Take some time, go ahead and solve it. We'll answer questions in the next class when it's live, okay?